Greetings, everyone. This is Eric Andelin, Senior Workflow Specialist with SimActive, and you're joining us for the webinar, Can 10,000 Drone Images Be Processed Overnight? And with me, I have my guest, J.D. Darville, UAS Program Administrator with the Alabama DOT. J.D., say hi.
Hi, how's everybody doing?
Very good, very good. We're all well. So you and I were just recently at the iHeap conference in Salt Lake City. Do you want to kind of give everybody a little rundown on what that conference is?
Yeah, so the Highway Engineering Exchange Program is a conference that's been around since 1959. It's a DOT conference for DOTs, hosted by DOTs. I've been going since 1998, so every year I have an opportunity to come out and learn what other DOTs are doing, and then hopefully take something home and put it to use in our program.
I like to tell my peers, you really should be there if you want to do any work with a DOT. You get to meet a lot of great folks. You get to show them what you can do, what your, in our case, our software, in the people that manufacture the drones, what the drones can do. It's not like going to commercial UAV Expo. We're actually here with all the people that do and that run these DOTs. So you are kind of, maybe by default at the forefront of the UAS side of things. So give us a little bit about yourself and the program at Alabama DOT.
Sure. So I was approached in January 2016. At that time, I was headed up our GIS group. I had been looking at possible drone use at the DOT. Was called upstairs to the front office and asked me if I was interested in starting a UAS program. So I went ahead and started putting things together. I was still heading up GIS, but went from there. And right around 2019, we finally got to hire some folks. So we had to go through the whole gamut of creating positions. What we were after, was it going to be central office? Was it going to be out in our regions to begin with? Things like that. So a lot of time and effort went into to get the program up and running, but we've been going strong since then. Just to give you an idea, last fiscal year we did over 4,000 flights. This fiscal year we topped 4,300. So we're on the go. Like I said, we are centrally located. We cover the whole state. There are 7 pilots, including myself, and we run the gamut. Whether it's ortho imagery, 3D modeling, 360 panos, construction update, progress flights. So we are busy. So which is a good thing, but my group loves it. I think it's headed in the right direction. And when it comes to HEAP this year, this is the first year we have a separate track for UAS. So it's growing. It's not going away at the DOTs. The nice thing about it is this year we have 26 DOTs participating just on the UAS side of things. And next year it'll grow. So for our first year, I'm pleasantly surprised and looking forward to the rest of the week.
Yeah, having been going to iHeap conferences for quite a while, it is nice to see the UAS side and its track go in that direction. I agree that it's not going away in DOTs. In fact, you'll see more and more of it, and there's plenty of reasons for that. But for you guys, it's another tool in the toolbox, like survey equipment, like anything else. You have the capacity. The software to process that data yourselves. You guys also have subcontractors that do that work for you as well. So I think that that works out really well. I'm glad to see, especially in the DOT market, drones making a nice footprint for themselves. So in this webinar, capturing large amounts of images, that's the challenge. Validating and preparing all of that to ingest into the software and process and things like that, how to process large projects, and that's with Correlator 3D or with anything else, and then preparing those results for delivery to the stakeholders and things like that, which you guys have to do. So projects that involve large amounts of imagery, they may take multiple days to capture. What are some of the things that you guys do? We're talking about in case of one of the projects you showed me, Selma, Alabama, there's, more than 10,000 images involved in that. So, how do you guys deal with that on the DOT side, from the collection all the way to, getting it ready to, or assembling it to put it into the processing software?
Yeah, so Selma was a unique situation due to, the tornadoes. So number one, it's a tough environment to fly in.
Yeah.
You've got to get in there. Your pilot's got to be safe. There's a lot of moving parts and pieces going on during the first initial 48 hours with first responders. We're in there trying to do our job. It was a massive area. Like you said, 10,000 plus images. So our goal is to get out there, boots on the ground, get our birds up in the air, fly it. And then the next job is you can fly everything you want, but if you can't get that processed and delivered to the decision makers, you've actually, you've got a bunch of images of what you got, which is nothing. So our goal was to get that stuff processed as quickly as possible, get it to the decision makers, let them do what they wanted to do with that data. So it went all the way to the front office, to the city of Selma, to consultants that we had to get that data delivered to. So it's imperative in those types of situations to get get that data in the right hands as quickly as possible.
So in a case like that, and we've talked on other occasions, are you flying multiple drones? Are you flying just singles? I believe you're flying Wingtra at this point, correct?
Yeah, so big projects like that, or corridor projects, we're using our Wingtra 1 Gen 2.
Yeah.
We love that drone. I forgot the last count of how many acres. It's astronomical how many acres we've flown with that in 2 years. So, when you start flying a 77-mile corridor in West Alabama and they need the data yesterday. So, we were flying all day, processing data at night, and, getting it ready. We actually flew it in 3.5 days and had the data delivered, I think, within a week. We were done processing and adding into a GIS system for them. So,
yeah.
But again, data sets like that are becoming more and more common, and you've got to be able to process that data and get it in the right hands.
Right. So, you're dealing with your pilots are probably part of your, experienced survey members as well. So they understand PPK, they understand control, all of those things. So that works out great. And, on those longer corridors, you're flying all day. So, setting up the projects is a big challenge, making sure that you're capturing, during sun angle. You never know when clouds are going to come by and blow your day. So, that's always a challenge. So, you got to be prepared to be on site and ready to go. And then you guys have, maybe in a unique situation compared to others, that you've built the processing workstations, the capacity to process these large data sets, correct?
Yes, sir. So we have a virtual rendering farm that I worked with our IT group. So we've spent a lot of time with them putting that. We're getting it built, and then working the kinks like anything else. Something new, you got to work the kinks out. But it's been spot on for us. It's nice to use. And again, I have the ability to go rip a bunch of images if I need to, and that's important, for us. And it's not something I use every day, but when you need it, you need it. It's kind of like our UAS command center. We don't use it every day, but when we have to have it, we have it. And it's available and it's at our disposal. So those are things we're looking at. And, cloud-based stuff right now is more and more common. So we're looking at that too. There's viable options there. So, and I will tell you this from my perspective, data sets are getting bigger and bigger. The equipment's getting better, the cameras, the resolution, and then you throw in maybe LiDAR and things like that. Data sets just continually get bigger and bigger. And that's not going to change.
Yeah, you're absolutely right about that. And, depending on the resolution somebody wants, those files can get really, really large. So a question though, do you, when you guys are out in the field, collecting, over multiple days or anything like that, are you doing any processing in the field to validate that you've collected everything, or are you content with the flight management software, ensuring that you've captured everything that you need?
I think for us, depending on the project, we'll do a cursory glance of the data just to see if it's what we need or if we've got the right stuff. If it's a bigger project like Selma or the West Alabama Highway, we will definitely take the time to look at that data to make sure we've got what we need. So,
Yeah.
and yeah, it slows us down just a little bit, but once we're confident that we've got that data, we don't check it anymore. We'll start flying and just keep going, flight
Yep.
after flight after flight,
Yep.
and go from there. So,
yeah, and I've looked at, obviously I've looked at the data set. I've run it through correlated 3D, which you guys have as well. One of the things I noticed is you capture quite a bit of overlap, and that's prudent because you're up there. You want to capture as much as you can and make sure that you have the coverage that you can. But in the demo that I'll get into later on, I'll show folks how. If speed is the driving factor, how you can go ahead and eliminate some of those images, some of those flight lines, things like that to make your processing faster. But I completely understand that you want to capture as much as you can because it's better to have more than to come back without it. So I assume
absolutely.
That's why you guys are doing that.
Yeah. Yes. Number one, we fly, depending on the project, our typical overlap could be 70-70 or 75-75 for nadir.
Yep.
If doing the modeling side of things, it could be more.
Yeah.
It just depends on what we're trying to do. So, but yeah, I don't want to have to go out and fly something and turn around and say, oh, we didn't get the data we needed. We got to go back. So that's time and money, and that's something we try to avoid.
Yeah. Yeah, well, I'm sure you guys have pretty much standardized on how you're going to collect the data, depending on what the output is, and then from there, again, if you've got really large data sets like Selma, I assume you're bringing those back into the office, to process in the farm, shall we say, just because of the processing power required to knock those kind of data sets out.
Yes, yeah, we do. So we use that. We use, SimActive, 3D correlate. We've used some other softwares too. It's like anything else. I tell people it's different drones for different projects, different software for different deliverables. And how can we get stuff out there in the proper hand? So it's not a one-stop shop.
Yeah.
And that just comes from experience, I think. So, and our team is well versed in, if we go to a site, we know what we're flying. We know what we need to bring to get that data, to collect that data and then get it processed and get it out.
Right. And kudos to you guys for building that infrastructure so that you can handle whatever, like I said, whether it's LiDAR, whether it's, imagery from a Skydio for, a structure or, something you can process in the cloud. You've got all those options at hand so that you can get the data out to somebody, as soon as possible. Another question I had, so the Selma project, was that originally for just, emergency response so people could get a view, or was it more you guys were, working on, corridor work in the area and needed to pick that up?
Combination of all the above. So number one, it was to get it in not first responders, but the governor, those people wanted to see what was going on, what happened. Secondly, it was delivered to the city of Selma so they could start planning out what they were going to have to do to get the city back open, roads open, debris removed, those type of things. So I call it 360. So you go out, you fly this stuff, you deliver it. It's full cycle. It just keeps going and going to different people. So, and that's the whole idea of these data sets.
Yeah.
If we can go out and fly it once, deliver it to whoever I need to, they can distribute it to whoever they need to. So whether it's first responders, DOT personnel, out in the region, city personnel. So all those things factor into something like that, which was a natural disaster. So.
Mm-hmm. Do you guys, in that case, are you housing the data and serving it yourself, or is it going to another entity that's taking care of that, another, CDGIS or,
We can do both. We can do both.
Yeah.
We can do both if we need to. So a lot of times it's easier if we push it up to the cloud and let it, get it distributed out that way. Sometimes that's quicker. Sometimes in the city of Selma, actually they had no internet or nothing, so we had to hand deliver a hard drive because all the damage out there. So, and that's what we did. We hand delivered a hard drive with all the data on it, and let them start their procedures and what they need to do to get the city of Selma back opened up.
Mm-hmm. Okay. One of the things I'm going to do, and this is, after you and I talk, I'm going to go and I'm going to show people, again, some of the ways that you can process the data in correlated 3D, how you can speed up that processing, things like that. Again, at iHeat, you've opened up this opportunity for not only ourselves, but other folks that have processing software, folks that have different drones, to come in and showcase what they're doing, how their processing works, how it matches to control. We've got a test site in that you're working with right now, and we're all processing the data, and we'll be talking about that again during the conference. And I'll share the results of that stuff in our webinar as well from what we did. But what other things do you see on the horizon with the drones? I mean, whether it's hardware, whether what do you want as we move forward? We all have wish lists.
Well, we do, and I still do. We're expanding our horizons. We're about to get into some hydrographic surveys, so we're actually going to buy a little. It's a 1 meter boat with remote control. You set up the flight lines or drive lines, whatever you want to call it, just like you do a drone, and
yep.
With a single beam echo sounder, and go out and start doing some hydrographic surveys with those. So that's one way we're expanding. I'm also expanding. We are starting to locate some folks out in the regions. So what that does for me, it opens up some more doors, but it also means I've got to have more equipment. I've got to make sure those guys are taken care of. So all those things come into play. And technology, this, Eric, as much as anybody, it changes almost daily now. Mm-hmm. So my goal is to, number one, do my homework. And I'm looking out for where we're going to be in a year, 2 years, 3 years down the road. So we're planning for that. Do we meet our goals and objectives every time trying to get there? No, because technology changes and you're like, well, that's kind of obsolete now. I want to go here, but that's not going to change. I don't care if it's CAD software, drones, hardware, software. That's going to continue. So I think it has to. That's a driving force for what we're doing with UAS. I mean, and I love it. And the data is getting better and better. It gets bigger and bigger. So you got issues there, mm-hmm. But I think you want the best that you can provide for your end users, and that's going to include bigger and better technology. Mm-hmm. And that's the way I approach things. I've always approached that throughout my career at DOT, which is 34 years. I've always looked at software, and I want to move to the next step. I don't want to be left behind.
Yeah. So
and that's how I've approached our UAS group.
Yeah. So, to that point, the Wingtra, the latest version, has a much larger camera in it now. What's a 60 megapixel or something like that? Or you guys are working with that, correct?
So I don't own one yet. We were looking at purchasing one. It's a 61 megapixel camera.
Yep.
It's a wider angle. Mm-hmm. So you're getting mm-hmm. a lot more overlap, but a lot less images. So there's a trade-off.
Which allows you to fly a lot longer.
Yeah, so you got to look at those things. So, and then we're also looking at LiDAR, being mainstream at ALDOT too, from a drone perspective. So we've got a test site set up for that. So we're doing some testing right now. Hopefully within the next 6 months, we're going to make a purchase and go from there. So we're working with some different vendors. Mm-hmm. But again, that technology, just the sensor technology on that side of the game changes.
Amazing.
It's crazy. So, but either my philosophy is either you can change or you can sit there and do it the way you've always done it, and you're just not going to move forward. So, and you can't do that in the drone industry or the UAS industry. You got to be willing to jump out there and take advantage of what they're offering. Our vendors, they've got great hardware, software like SimActive. Those are things that people need to take advantage of. So. Mm-hmm. That's the way I'm going to approach it until they run me out of the door. So,
well, we appreciate your your time with us, your input. When you and I get together, we talk software, and you make your suggestions about how things could be better, could work better. We're certainly doing that on our end, like you say, as technology's changing. And again, I'll talk about it here in the demo, but thanks for giving us some time. If you got any closing comments, bring them on.
No, I thank you for the opportunity to sit down with you and talk about all things UAS and the software side of things. So,
all right. Well, thank you very much.
Thank you, Eric. Talk to you later.
Talk to you later. All right, so let's move on to the demo portion of the project. Let me load the project that JD and I were speaking about, which is Selma, Alabama. This is part of the data set that JD and I were talking about. And we can see that there are 8,971 images here. Let me make that easier for you to see. We'll turn off the online data. And here we can see those 8,971 images. What we can also see is that there's quite a bit of side lap, one, and two, that there's quite a bit of overlap between these various flight lines. So let's look at how we can clean that up. Now, so that you get a good reference here, I've actually loaded this flight information into QGIS so we can look at it by actual flight. And it looks something like this. So we have 1, 2, 3, 4, 5, 6, 7 different flights for these close to 9,000 images, and these were done over 3 days. So if you consider the whole project's like 17,000 images, there's a lot of images here. And granted, we can process those on a single processing workstation. That we can do no problem. But you want to process this stuff as fast as possible to get to a good result without diminishing quality. So let's go back to Correlator 3D. And before we start processing, when we go into the AT module, we can do some flight editing. Okay, so let's do that. It's going to want to create tie points for aerial triangulation. We don't want to do that just yet. So let's just say no to that. And then let's look at our flight line editing possibilities here. So first, we want to look at all of the images and flight lines we have. And you can see we can turn them on or off here. So let's go to the editing tool. Okay, and it'll pull up a screen right here. So now we have some options with our editing tool. And what you could do is you could go in and grab these by a rectangular section and remove them. But what we want to do first is we want to look at the flight lines, and we can turn these on or off or remove them from the project. Now, when we delete a flight line from the project, say for example, this flight line here. So this is flight line 1. When we delete this from the project, that's all we're doing. We're taking it out of the project. We're not deleting images or anything like that. So let's do that first. So I've removed flight line 1. I'm going to remove flight line 3. And the reason I'm doing this is because we have so much side lap on this project, we don't really need all of those. And I'm going to do flight line number 5, and like so, until I go through all of these, which I will spare you. We will just fast forward a little bit to these that are completed. Hang on a second. Okay, so there we've eliminated basically half the images in the project without degrading the quality of the project. And part of the reason for that is that Correlator 3D is just not everyday structure from motion software built for modeling. It's actually built for mapping. So we work well with 60% overlap, 30% side lap. We are a photogrammetry software. Our AT is built for that, so we can handle that. Now, what I'm going to go ahead and do is save this configuration. And we're going to hit apply. And now you can see we are down to 4,449 images. Okay, so now that we've reduced our image count by half, we could go ahead and process this. I'm going to go ahead and get out of AT. We're going to use our automated workflow, but we're not going to go all the way through the steps. So we're going to do the workflow by step. Now, again, this was for emergency response, the collection after the tornado. So what we're going to want is one of three things, either a quick project overview, and we could let that rip through and it would create the deliverables. Again, a coarse DEM, accuracy is fast, and the ortho itself will be coarse, so it won't be at the highest resolution. So you could do that. If you're in the field, great way to do it. If you're out there overnight, you want to inspect your data set, make sure that you've got coverage. This is a great way to go. The next thing is a fast ortho. The only difference is it's going to create that coarse DSM. The accuracy is going to be fast, but the resolution is going to be optimal. So you could do that as well. That will give you the best resolution or the optimal resolution, yet the surface itself, it's not going to worry so much about the vertical accuracy. And honestly, there's no control associated with this. So you're probably fine running that. And then the other option is to do classic photogrammetry, true ortho, or 3D model. But what we're going to do is we're going to go with classic photogrammetry, but we're only going to do the AT. So let's go ahead and turn everything else off. And you can see if we turn off DSM generation, everything else turns off below it. And what we're doing here is we're just going to run the AT before we create any kind of DSM, and we'll go ahead and run that now. Process that. And again, because this is a large data set, we'll skip ahead. Okay, so we've got our project summary on the AT, and everything looks good in here as we scroll down. The standard stuff. Everything looks pretty good. So we'll move on, hit OK. We don't need that anymore. And we want to actually see those tie points. So let's turn it on and we'll take a look at those tie points. And here's what we have. And you would expect on such a large project, you might have some holes in the data. So we have that shown here. Now you could go add more tie points in here, but most likely it's because of vegetation of trees. Actually, we can take a look at that. We can go to the online data. And sure enough, we see vegetation and trees in these areas. So we would suspect that we might see those gaps. Now, this doesn't mean that the data is going to be bad. The data is going to be just fine, because you see the data set shows up green with less than a pixel of error. So we're still in good shape there. It might create a few challenges for the DSM. So we'll go ahead and work with what we have. But the reason that I wanted to do it in the automated process in pieces is just for this purpose, because when we do produce the DSM, if we were to run a complete automated solution, we may find, and then it goes on to create the orthos and so forth, we may find that there's an issue with the DSM that affects the orthos, that affects the output mosaic, and we want to correct that. So what we'll do is we'll create the DSM, make the corrections, then let the rest of the automation run. So we'll go ahead and do that now. We'll get out of AT. And again, in this project, this is tornado damage assessment data. So there are two things that we need to consider is that, we're probably not looking at the highest vertical resolution or the highest horizontal resolution requirement, even though at 400 feet, we're going to get good data anyway. But to output something quickly, let's just go ahead and we'll run a coarse DSM. So we'll go here, back into the automated workflows. We'll turn this off. We'll go to DSM generation, which we'll turn to on, and we'll change the resolution to coarse and the vertical accuracy to fast. And then we'll go ahead and turn these off as well. Okay, so everything's off. We'll let it run. And once the DSM is finished processing, we can take a look at it, inspect it, and we'll go ahead and turn the images off. And yes, as suspected, there's a few holes here and there, so forth. Not a lot to worry about, but let's go ahead and create the DTM and we'll clean those holes up. To create the DTM, we'll just go right here and say extract the DTM. And we'll leave everything as it is and we'll hit process. So here we have our DSM, and we'll just go into the editor and make some corrections, fix some things in the DSM so we can produce the orthomosaics. And there we are. Now let's go ahead and produce the orthos. Now here, again, we can go back to the automated processing or we can do it manually. I'll just go in here manually because I want to see what the overlap was. Okay, so we want 65% overlap, which is good. It's going to be DTM based, not DSM based, so we'll leave that alone. We don't have a boundary extracted for it yet, so we'll just process what we have. And the next thing we want to do is, we can do 0.5 foot resolution, but do we really need that when we're looking and assessing tornado damage? So let's just make this 0.25, which will make things happen faster. And we're going to use GeoTIFFs. So everything is good. Let's go ahead and run it and we'll hit process. And you can see as it's processing down here, it's showing you the images as they're being orthorectified and their location. And you'll notice, one, that there is quite a bit of forward overlap, probably more so than you needed. So you could have, as I explained earlier, removed half the photos and been fine. But we'll watch it when it comes back the other direction and we'll see what the side lap turned out to be. Here we go. Here's the next flight line. And you can see there's still plenty of side lap as well. So taking away one flight line or every other flight line didn't change the properties of the project. So we'll let that run till it's done. Okay, so now we have our orthos completed. So the next step then would be to create the mosaics. So let's take a look at that process. We'll go to mosaic creation. Okay, so we have our mosaic done and it is loaded here. We've got our mosaic. And now it's time to tile the mosaic. So export and tile the mosaic. So if we go here to mosaic editing, so here it is, it's in one large block. So obviously you probably don't want to export that large block on its own. So we go to export. Okay, standard mosaic, the folder that we're going to put it in. So we'll create an output folder. Okay, we'll select that folder as our folder. Okay, and yes, we'll go ahead and compress these, JPEG and TIFF. We will crop them. Again, we'll use the boundary as our crop file. And we can load that in. Here we go. So we got a boundary. And we also want to tile this mosaic. So you could tile it one of two ways. You can just tell Correlator 3D to create a tile size of X number of pixels. And then if you say 10,000 pixels by 10,000 pixels, it'll create a grid starting in the lower left and make sure that it covers everything that you need. and then export those tiles out. But in reality, we know we don't normally do that. We would tile from a file. So if we go here to File, and we'll browse again, right here, it's Tiles. And we've got that all set up. So now it will break it up into tiles based on this file. We go ahead and process. We'll open the results in QGIS. And so now there you have the image tile sets visible in GIS, so they can be served at any platform through any GIS application to all the stakeholders. One last thing, since we were talking about, originally, can you process 10,000 images overnight? Again, I want to go back to this and show you the performance report for this project. If we take a look at the performance report, you can see that we have 4,362 images. And if you'll remember, we started with about double that number because we eliminated some when we were setting the project up. So we have all of our timing set here. So tie points took a bit of time. The bundle adjustment, the DSM generation, the DTM extraction, ortho rectification, and mosaic creation all combined took 4 hours and 25 minutes. That's 4,362 images in 4 hours and 25 minutes. If you take that and you double it and add a little bit more, yes, you see that you can process these large data sets overnight. Also note that was done with just one workstation. We weren't using distributed processing or anything like that, so keep that in mind. When you look at processing power and how you're going to be able to deliver this data as soon as possible, you're going to want to use the right software, which I believe is Correlator 3D. You're going to want to filter your data set coming in, again, because you may have 70% overlap and 70% side lap. Obviously, you don't need to process all that data for something like a map product, especially in Correlator 3D, where we work perfectly fine with 60-30 overlap. So keep that in mind. Again, if you reduce the number of images in your project area by changing your overlap, that just means you can fly more areas per day. And as JD mentioned, he was talking about flying 77 linear miles over the course of a mission. So they are capturing a lot of data, and they have a processing farm that includes graphics cards that allows them to, process with not only our software, but other folks' software. Even if they need to send to the cloud in some instances, they'll do that. And they're working on increasing the performance of cloud-based processing as well, which you can do, again, with Correlator 3D. My recommendation is if you want to do something fast, do it in Correlator 3D. If you want to do it faster, then use our distributed processing. You're going to get a 5x increase in processing speed, depending on the number of workstations you add to that processing pool. So keep that in mind. We're very happy with the performance on one machine. As we said, in version 10.1, we doubled our DSM processing speed, which is typically the longest part of the project. So with that, again, thanks to my guest, JD. Thank you for joining us in this webinar. Remember that this webinar will be converted to a podcast. Both will be available on our website in the coming days. If you enjoyed this webinar, please share it with someone else. If you get to our podcast and you enjoy that, please share it on social media so folks know that it's available. Once again, thanks for joining us. Until next time.